process the age variable a little more, let's have a really in-depth output based on what you type in. So if you type in a number that's too small, we'll say you're too young or something, or if you type in a number that's too big, you're too old. So let's start with if age is less than or equal to 3, something like that. A 3-year-old can't type, right? So we're going to say cout, you are lying. Because obviously he's not telling the truth. He's not 3 years old. Now, this is going to work. We know this. We've done this kind of exact stuff in the previous tutorial, but we also want to check for some other things. We want to check if age is less than 12, for instance. You're too young to play. So we could do that. We could say if age is less than 12, then cout, you are too young to play. But what's going to happen here is both of these if statements are going to happen if we type in like a -1 or something, which I guess is okay because if you're -1 years old, you're lying and you're too young to play. But what if we only want one of these to happen? If we type in a -1, we only want it to say you are lying and we don't want it to say you are too young to play. Well, what we use is something called an else if. So what we're going to do is we're going to back this up right here onto the previous line, and we're going to type else right here. So if age is less than or equal to 3, we'll do this, else if age is less than 12, we'll do this and put our semicolons. So what an else statement is it checks this condition only if this condition is false, okay? So if this age is not less than 3, then it's going to check this one. But if this age is less than 3, it's never going to check this age variable, ever, okay? So, for instance, if we typed in a 4, is 4 less than or equal to 3? That's a false, so the else will happen. And then we'll check this one. Is 4 less than 12? Then yes, we're going to cout, you are too young to play. So let's test that. Let's see what happens if we type in a -1. You are lying. Good. And let's see what happens if we type in a 8. You are too young to play. See, it worked. Now, there's other things we want to add on here, and we can do that with just some more else if statements. Let's say if you're older than 90, you're too old to play. Else if age is greater than 90, cout, you are too old to play. Now, you may not like the way I'm typing this. I personally like this style right here because it's really easy to tell that your cout statements are inside the block because they're tabbed over. But you may prefer to do this, where everything is on its own line. That's totally okay too. It doesn't really matter. I just prefer the other way. The reason I don't like this way is because look how many lines of code we have now. It's a bunch more lines and it achieves pretty much the same thing. And why do I always forget to put semicolons at the end? So now this is going to work too. We're going to say you are lying, you are too young to play, or you are too old to play based on what age they put in. But what if we want to say something else if they are old enough to play? So if their age is greater than or equal to 12, or their age is less than or equal to 90. Well, we can actually do that check. We'll do another else if right here, and we'll say if age is greater than or equal to 12. Now, we have to say if age is greater than or equal to 12 and if age is less than or equal to 90, because if age is greater than or equal to 12 only, then this one should also pass too, right? Because if he's 100 years old, this is going to pass. So what we need to do is use an AND statement to kind of bound our range inside 12 and 90. And what the AND syntax is two ampersands like this. So if age is greater than or equal to 12 and age is less than or equal to 90, like that. And then we can do our cout, you are old enough to play, just like that. So the AND, what it does is it only evaluates to true if both of these are true. So this has to be true, age has to be greater than or equal to 12, and age has to be less than or equal to 90. It makes sense, and, right? That's exactly what you think when you say and. That's what the logical expression means. So let's go ahead and put our semicolons that we always put in the wrong spot, and then let's run it and see if that works. Let's type in first a 100, and we should get you are too old to play. Let's how do we zoom in Windows? There we go. You are too old to play, as you can see. So what if we type in a 30? We should get you are old enough to play, right? So how old are you? Zoom in. You are 30 years old. Look, you are old enough to play. and then I didn't put a new line. So it works. That's how you can actually chain multiple ones together. We can keep going. We can have another and, but it's always safe whenever you're chaining together Boolean expressions like this into one larger one. It's always good to put your little your sub Boolean expressions in parentheses. Now this is going to do the exact same thing, but it's just safer to do this because sometimes it can get confusing when you get lots and lots of these things all together. If we want a bunch of ands, we might accidentally check them in the wrong order or something. An and might get checked before a greater than or equals or something. So it's just good, like in math, to just use parentheses. Parentheses are free. They're not going to slow down your program or anything. So just go ahead and use more whenever you're in doubt. So there's another operator. There's an or operator, and what or means is literally or. If this is true, or this is true. Now it doesn't really make sense for this context, but you get the idea. We have and, we have or, and we have the equals operators and things like that for just comparing two variables and things like that. So with all of these tools in our arsenal, we can do a bunch of cool things with logic, and we can do lots of different comparisons to see if things are true. For instance, if we wanted to do tic-tac-toe, we could use the equal sign to check if everything in a row is equal to each other. We could say if A is equal to B and if B is equal to C, right? For instance, let's go ahead and give ourselves a little 3 in a row. Okay, here's x, x, x in our tic-tac-toe game. If we wanted to check if this x is equal to this x, we would use an if statement. And then we need to check if this x is equal to this x with another Boolean expression, and we can just chain these Boolean expressions together with an and. So I hope that made a little bit of sense. That sounded confusing when I said it, but this is how we're going to kind of build our basic games up. It's going to be using lots of logic. We're going to try not to have too many of these huge long else if statements, but this is kind of something that you could use when you're beginning to make a little text adventure and learn how the actual Boolean logic works. So be sure to stay tuned for the next episode. We're going to go over something called a loop, and it's going to be super cool. Actually, I forgot to mention, we don't actually need this last if statement. What we can do instead is just make it an else. And now what an else does is it means if all of these are false, then this is going to happen. And in this case, that's what we want, because if age is less than or equal to 3, you're lying. If age is less than 12, you're too young to play. If age is greater than 90, you're too old to play. And if they type in any other number, which is going to happen to lie between 12 and 90, then they are old enough to play. So we don't even have to use that if statement. We can save ourselves a comparison and just use an else. And what that means is this will always happen if none of these happen. And we are guaranteed that one of these cout statements is going to happen before we get here. Anytime you have an if-else, you are guaranteed that one of them is going to happen if the last one is else, like this. Now you can't have multiple else. That doesn't really make sense. You can only have one else at the very end, and that's just kind of the final case. If everything else fails, oh crap, all of these failed, here's our last ditch to do